Well, hi everyone. Thank you for showing up for your learning. In this video, we're going to take a look at how we interpret the graphs of quadratics in context. Okay. Sometimes they're going to give us graphs, other times we're going to have to use graphing technology. So let's kick on some Desmos here. Some cool Desmos action. All right, so let's go back over to Delta Math. And we're going to get into graphs of quadratics in context. Okay, a skydiver jumps out of a plane from a certain height. The graph below shows their height h in meters after t seconds. How long is the skydiver in the air? Okay, and so we need to know here, this is height in meters, this is t seconds. Are they in the air here? Oh no, oh dear, their parachute didn't open. That's really tragic. This is really a sad example. Anyway, here they are. They get out of the plane. They're initially not going very fast, but they start to accelerate. Gravity pulls them down, 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 down. And after 23 seconds, their height is zero. If your height is zero, that means you're a pancake on the ground. So they were in the air for 23 seconds. And we'd know that from looking at time in seconds. A skydiver would probably jump out, pull their parachute here, and their speed would change to a very shallow line because they hit terminal velocity with their parachute out, and a terminal velocity that will not pancake you when you hit the ground. So that's why I don't like this graph or this example. Let's look at a new one. Okay, here we go. A rocket launched into the air. Well, I can do that. I like that. That's fine. A rocket is launched at time 0. It goes up, 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 up. After 14 seconds, it's reached its maximum height of 960.4 meters. Wow, it went almost a kilometer in the air. And then it came down after 28 seconds. That seems a little fast. But anyway, let's see. The graph below shows the height of the rocket in meters after t seconds. How long is it in the air? Well, again, we're just going to check how long was it up there? It was 28 seconds. If they said what was its maximum height, we would say this. If they said what time did it reach, how long did it take to get to its maximum height, you would say that. That's its time. 14 seconds to get 960 meters into the air. So these are these types of questions. But what if they don't give us a graph? Adriel kicks a football. Good for you, Adriel. Its height in feet is given by h of t is equal to negative 16t squared plus 80t, where t represents the time in seconds after kick. What is the football's greatest height? Well, let's go ahead and take that in. So minus 16t squared plus 80t. So we're just going to use x. Minus 16x squared plus 80x. Boom, there it is. Okay, so we could restrict the domain here to say that y is greater than or equal to 0, but we'd really be being fancy there. Why didn't that work? Strange. Anyway, we're not going to worry about that. We don't need to be too fancy. Oh, look, it stayed in the air for 5 seconds. Okay, its maximum height. I didn't think this equation looked particularly realistic, but it reached a maximum height of 100 meters after 2.5 seconds. That's not what footballs do. They don't go 100 meters in the air. So it's not a very good equation, but the answer they're looking for is that 5 seconds, okay? So this requires you to look at Desmos with points labeled and understand what those points mean. So this answer is 5 feet. Oh, wait, what was the football's greatest height? Oh, it's 100 feet. Yeah, that I can believe. 100 feet, yeah, I could go 100 feet in the air. And then maybe these numbers are correct. So suddenly you change the scale, and I like your equation. So at the answer, 100 feet, yeah. All right, so that's how you do those. So let's look at another one. Hua kicks it. Oh, they're all kicking footballs. Minus this one ain't going to go so high. Interpret the coordinates of the vertex in context, okay? Well, we've already got that mostly written down here. We just need to change this to 32. She does not kick it nearly as high. So let's see. It's maximum height, 16 seconds. Happens after 1 second. Let's see what they want to know. The x-coordinate of the vertex is 1, and it represents how long the football has been in the air at its peak, because it's the vertex, that's the peak of the football. The y-coordinate is 16, and it represents the football's height at its peak. Submit the answer. Hooray! And don't forget this. Don't forget to give yourself a pat on the back when you correctly interpret a graph. Okay, thank you, everyone. If you have questions, send me screenshots of the questions that confound you. Otherwise, hit me up on Tuesday or send me an email. Bye for now, everyone.